started, but I think it's time to get underway now. I just have a couple of housekeeping things. We're going to do about a 10 to 15 minute presentation. That is, Professor Idle will go through his rather scientific and technical presentation for you. If some of the content seems beyond your scientific knowledge, don't worry. We'll have an open Q&A session at the end of the presentation, so you can ask anything you like for clarification or relevance of what's going on. At the end of the question and answer period, all of the panelists will be available for one-on-one chats if you want to take them aside, and we'll stay around for about 30 minutes for that kind of thing, if you care to talk to them privately. And as you leave the room, we have a full press pack prepared for you that includes the full text of the report, an executive summary, a press release, and the full biographies of all 6 panel members. So without further ado, I'll turn it over now to Professor Jeffrey Idle.
Thank you very much. Welcome, ladies and gentlemen. I'm sorry if those of you who got here largely on time have had a prolonged wait, but we thought we should start anyway now and let the stragglers appear when they're able to arrive. My name is Jeffrey Idle. I'm Professor in Medicine and Molecular Biology at the Norwegian University of Science and Technology in Trondheim, Norway, which was known formally as the University of Trondheim until the end of December last year. When we started our work, last year I was at the University of Newcastle here in the UK as the head of the School of Clinical Medical Sciences and Professor of Pharmacogenetics. I think we should start by me introducing to you, if I may, those members of our panel who've been able to join us today. Over on your left, we have Professor Julio Benitez from the University of Extremadura in Badajoz in Spain, who is a clinical pharmacologist. And next to him is Dr. Anthony Springall, who is an independent consultant in applied statistics from Cleveland here in the UK. And over on your right-hand side, we have Professor Marcel Robefoy from the Catholic University of Louvain in Brussels, who is an expert in chemical and food toxicology. There are bibliographies of us all, and the other 2 members who are unable to join us today in the reports which you'll be receiving, the full report which you will receive in the press pack at the end of today's session. Breathing environmental tobacco smoke is not the same as smoking a cigarette. We wanted to examine the scientific evidence that environmental tobacco smoke and lung cancer may or may not be linked in some way. And so I assembled a panel from across Europe of individuals who could contribute to this question in various areas of expertise. And we have, after our work of some 8 months or so, produced a report which is available for you today. And what I'd like to do is to describe for you our multidisciplinary approach, which unifies data in this whole area and looks at the weight of evidence that environmental tobacco smoke and lung cancer may be linked. However, the news is that there is no reason to believe that lung cancer is caused by breathing environmental tobacco smoke. Okay, I'm going to use the overhead projector and keep these to a small number. The first area which we examined as a panel was exposure to environmental tobacco smoke, because I think this has been insufficiently looked at hitherto. We reviewed the literature on levels of the chemical constituents of environmental tobacco smoke in indoor air, and we pulled together the data that exists on concentrations of chemical components of environmental tobacco smoke. We also calculated likely levels in indoor air situations from first principles, from a rather simple arithmetic calculation. You don't need to have a degree in science in any way at all to understand what we did. In the literature are published the yields of various chemical components in both side stream and mainstream tobacco smoke. That permits you to calculate, if you say that someone smokes, for example, 15 cigarettes a day in an office of a certain size shared with a certain number of other people, the chemical constituent levels that there will be in the air. And when you do these calculations, they produce results which are very, very similar, if not identical in some cases, to the levels that have actually been measured when people have gone out and measured them. So the model, the calculation allows you to determine levels of other chemicals which have not yet been determined. And when you calculate these levels, and we were very surprised to find these levels are extremely small, and we needed some benchmark against which to compare these low concentrations of chemicals in indoor air that derive from environmental tobacco smoke. So the first place we looked were in the occupational permissible exposure levels that are set for these individual chemicals in the workplace. You must appreciate that most, if not all, the chemicals that exist in environmental tobacco smoke occur in other situations in the environment, including the diet. Many of the individual constituents of cigarette smoke or environmental tobacco smoke have been regulated for in an occupational setting, for example, formaldehyde and so on, and I'll come to a couple of examples in a moment. And judgments have been made about a threshold above which it is unwise to work and below which it is permissible to work. And we compared these concentrations of chemical constituents of environmental tobacco smoke with these occupational permissible exposure levels. And we found that the permissible exposure levels are between 10 and 1 million times higher than the levels of chemical constituents of environmental tobacco smoke, with the average value being around 10,000. 10,000 times below, in other words, the permissible exposure levels. So these concentrations are very low. We also did a comparison with diet and this level of chemical constituents of ETS that are present in the diet and how they compare. Let me just start for a moment with formaldehyde. I think you all know probably what that is. Breathing environmental tobacco smoke for a period of 8 hours, you will have approximately 230 microgram absorption, 230 millionth of a gram, in other words, then, absorption of formaldehyde. The diet per day gives you between 2,000 and 40,000 micrograms. In the case of formaldehyde, the occupational margin of safety, the permissible exposure level, is 35 times higher than the levels of formaldehyde found and calculated in indoor air. Benzoate must be one of the most widely studied animal carcinogens. It is present in environmental tobacco smoke. If you breathe ETS over a period of 8 hours, you can readily calculate that you will absorb about 8 nanograms, 8 billionths of a gram of benzoate. The diet provides up to 50,000 nanograms of benzoate. The occupational permissible exposure level for benzoate and other polycyclic aromatic hydrocarbons is some 200,000-fold higher. In other words, levels of benzoate in indoor air where people are or have smoked are 200,000 times below the permissible occupational exposure level. That brings us to nitrosamines, which is in there as another example, a generic group of chemicals present in ETS and many other places in the environment. If you can see this, I know I'm in the way, I'll lean out of the way. Try and move it up a bit here. Breathing environmental tobacco smoke over 8 hours will give you less than 1,200 nanograms. All this information and far more, ladies and gentlemen, is tabulated in this report. The diet per day gives you between 300 and 1,800 nanograms. So the contribution of ETS to nitrosamines is approximately the same as the ordinary diet. We also reviewed the epidemiological studies, the population-based studies which have been carried out, and upon which which has provided the single most important pillar in the past for regulation and for evaluation of environmental tobacco smoke. There were 48 published studies which we analysed as a working group, which broke into three types: spousal, largely exposure of non-smoking wives to smoking husbands; childhood exposure; and occupational exposure. And two of these, the large group of and homogeneous group of US spousal studies, gives a relative risk of 1.01. A relative risk of 1 means no increased risk. 1.01 is a 1% increase and is not statistically significantly different from no increase in risk. The workplace studies that have been published, analysis of those gives a risk of 1.04, which again is not significantly different from a 0 increase in risk. So we can say the bottom line of the epidemiological studies is an analysis of these does not support an increased risk of lung cancer from environmental tobacco smoke. The working group also examined the diet. Diet being an important component in human cancer. Approximately a third of human cancers are thought to be related to the diet. And we wanted to examine what impact that could have on this. Lung cancer is a tumour which is responsive to dietary changes, and there have been many studies on this. I'll just say at the outset that there are approximately, it's not quite in focus, there we are, approximately 20,000 A-nutrient chemicals in the diet. These are chemicals that you absorb in the diet for which you get no nutritional value at all. For example, toxins that are present in plants and so on. Most ETS components are also found in the diet. A diet which is low in fruit and vegetables, and particularly the antioxidant vitamins, increases lung cancer risk. We looked at the studies in this area, and there's very strong evidence now that a low level of antioxidant vitamins in the diet from poor intake of fruit and vegetables increases the risk of lung cancer. And therefore a poor diet must be adjusted for in the epidemiological studies. We also considered the mechanisms of carcinogenesis, and particularly host defense mechanisms. You may or may not be aware that we have many processes that defend our genome against chemical and radiation toxicity and damage to DNA. These processes include DNA repair, apoptosis, cell cycle arrest, and many others, and chemical detoxification. In other words, our tissues contain enzymes which are able to metabolize chemicals that are potentially dangerous or toxic and eliminate them from the body. These processes operate more efficiently at low exposure levels. And in the animal carcinogen bioassays, and these are the tests which brand or label a chemical as a carcinogen, when you think of a carcinogen, the word is a strong word. It suggests to you that it will cause cancer in humans. Half the chemicals ever tested in these assays turn out to be carcinogens, and they are so because animals are given very large doses, often between 100 and 10,000 times greater than humans are exposed to. And when animals are exposed to these huge doses of chemical carcinogens, they overwhelm the host defense mechanisms that I mentioned to you, and then you get onto the carcinogenesis pathway. We also reviewed and discussed in our report the evidence that there is an adaptive response. This means that when you expose an animal or a cell to a low concentration of a chemical or indeed radiation, it stimulates a response within the animal that protects it, makes it better prepared for future chemical insults. Think of vaccination. When you take a baby and you give it a small dose of an inactivated bacterium or virus, which then gives it immunity, often for life, against future invasion by that organism. There is good evidence now that there are adaptive responses, including in humans, that prepare you for and protect you against further insults by chemicals. And ETS exposure is below a threshold for this toxicity. So having considered these and a number of other areas, just to keep it brief and we can deal with those subsequently, we came to our risk assessment, and using the terminology that the International Agency for Research on Cancer uses in its risk assessments of chemical risk, we found that there was insufficient evidence from the epidemiological studies that environmental tobacco smoke is a human lung carcinogen. We found that there was insufficient evidence from animal studies that ETS is a lung carcinogen in animals. We found that there was insufficient evidence that ETS causes exposure to toxic chemicals which are even close to a threshold for concern. And let me just point out again that the average level that ETS components find themselves in indoor air, the average 10,000 times below the permissible exposure levels for occupational exposure. And having considered the weight of evidence, it is the judgment of the working group that environmental tobacco smoke is not a primary lung carcinogen. In other words, there is no reason to believe that exposure to environmental tobacco smoke causes lung cancer. At which point I will throw this open to questions.
Yes. Michael David, New Scientist. I just wanted to ask how you distinguish between environmental tobacco smoke and things like the side stream tobacco smoke. So I imagine if you walked into a factory where someone had smoked a couple of days ago, there wouldn't be much residual tobacco smoke. However, if you went into someone's house where two people smoked and it was quite small, there'd be lots of tobacco smoke. How did you know that was?
No, environmental tobacco smoke is the term used in the literature for passive, for what other areas have called passive smoking. In other words, it's an entity, it's a chemical and physical entity. It's not something which you have to have a person there for it to exist. If you say passive smoking, you have this view of someone breathing it in. Environmental tobacco smoke is the material which you breathe. Of course, it does age. You're absolutely right. It absorbs onto surfaces. There are chemical constituents of ETS which will decrease in concentration because of lighting. I know it's pretty dim in here, but in most modern lighting and outdoor air and outdoor sunlight, of course, destroy many of the chemical constituents of environmental tobacco smoke. So it is a mixture of exhaled mainstream smoke and side stream smoke, which ages, absorbs onto surfaces, and we deal right in the front of the report with a definition of environmental tobacco smoke. But it is a term that's used in the scientific literature to explain smoke that comes from smoking largely indoors.
So let's quickly follow up there. In the summary, you said that you think that environmental tobacco smoke isn't a lung carcinogen. I mean, how does that apply to a situation where people are concerned, being in a bar which is small and might have 20 people smoking? Would that be the kind of ETS you're talking about? Because most people, if it's stinging their eyes and they can smell it and it's in their throat, they would be concerned. I mean, would you apply your conclusion as confidently to that kind of situation?
I can see where your confusion arises from.
I'm not confused. I just wanted to get the distinction, because I can see how levels could vary very widely between being in a field and being in a small bar where there are 30 people smoking.
We've calculated the concentration of chemical constituents from smoking based upon an occupancy of 36 cubic meters per person. That's a sort of 3 by 4 by 4 meter space, the sort of area you work in at work if you look at what volumes people occupy, and there's plenty of data on this. And in an area where 25% of the people are smoking, which is approximately the national average, most about 25%. And when you use that in the calculation to generate calculated levels of ETS constituents, and compare those with levels that have actually been measured, and they have been for nicotine and carbon monoxide and several other things, you get almost exactly the same answer. So we know that any assumptions we make are very valid. But so remember, what we have found, and what we were surprised about, was that these levels are on average 10,000 times below levels that you can find in an industrial setting that have already been regulated for. So if you were to put 2 or 3 smokers into that space and have you're talking about more closely packed environments such as a bar or whatever, where more people are smoking, and I don't think in my experience there are more people smoking in a bar than the national average. There are plenty of non-smokers in bars. You're not suggesting that smokers all gravitate to bars, but yeah, there's still a very large margin of safety.
So in a nutshell, these results and your conclusions apply to a situation where 25% of people smoke and have an average of 36 cubic meters each. Is that correct?
No, that's what we use to calculate levels.
Okay.
and compare them with the very large database of levels that exist that people have actually measured. You appreciate that some of the lower constituents, cadmium, nickel and so on, that are there in such trivial amounts, people have not been able to measure those readily in indoor air environments. And we were curious to know what sort of concentration they would be at. And that's why we did some calculations as well as review the methods, the literature. Yes?
May thoughts with Reuters. Since there is a very clear link between actually smoking and lung cancer, how do you account for the difference between environmental tobacco smoke and cancer and actually smoking a cigarette?
Well, I think, as I said at the outset, smoking a cigarette and breathing ETS are 2 very, very different things, if only from the point of view of dose and composition and nothing else. And we say this in the report. There are about 4,000 chemicals that have been detected in cigarette tar, in other words, that are in mainstream cigarette smoke. There are only 40 or so that have been detected in environmental tobacco smoke.
So you're saying it gets absorbed, the smoker absorbs things that don't burn out at the end of the cigarette and that they don't breathe out. Somehow these chemicals disappear in the act of smoking it.
Actually, most of ETS comes from side stream smoke that the smoker does not inhale. And the rest, between 10 and 30%, comes from exhaled mainstream smoke that the smoker has inhaled and then exhaled. What the smoker inhales, about 95% of that is absorbed by the smoker, and only 5% is exhaled. So obviously the composition of ETS and mainstream smoke are different.
Yeah. And if I would like just to add one thing about this, that also is a question of air dilution, because what you breathe in air is completely different from cigarette smoke because it's much higher diluted. So you are talking about much different levels of exposure.
This lady at the back was first.
From the Mundo, Spain. I just want to know which are the other consequences for the human health of the ETS, an environmental. I mean, if it doesn't cause lung cancer, which is there are any other things which are damaging for the health?
I can't answer that question. We are here to discuss the lung cancer issue. That's all the panel. That's all the panel has spent time reviewing, I'm afraid. Yeah. You were next.
Nigel Hawkes from The Times. How is it that you have come to different conclusions from other people, presumably based on the same studies? I mean, it was my understanding that the evidence indicated that there was an increased risk of cancer in the home situation, i.e. the spousal studies, although not such a clear one in the workplace studies. You don't seem to find that distinction at all. In fact, you don't find a risk in either situation. Is it that other people have selected their studies in a different way, or how do you explain this difference?
Well, I should probably ask Dr. Springle to answer that.
Yes, I think there are a number of points. The first thing is that it's been several years since an extensive review has been done in this area, and studies are materializing all the time. And there have been a number of studies that have occurred on each continent since
certainly the EPA review in 1992. The second point is that there's been a lot of science done since then. Been a lot of questioning about the way, in fact, the body reacts and so forth. So, and how human beings' lifestyle interferes with measurements in the epidemiological studies. And these things together, plus the fact that many reviews did not take the full account of the evidence. You mentioned the spousal studies. Now, the spousal studies have been very much concentrated on by most reviewers, and yet about, in each case, half of the studies have also used working with colleagues who smoke as a measure, and also growing up with smokers as a measure. Neither of these two show any increased risk. Now, the problem with the one that does appear to show an increased risk, spousal smoking, is that it's a very poor measure. Let me give you a little bit of background, first of all, on epidemiological studies. Epidemiological studies are not your classic scientific experiment. They are observational studies. They're much more like opinion polls than they are an experiment in engineering, in physics, in agriculture. There's very little control over them. And this means that it's been long recognized by epidemiologists that if you have relative risks below 2, you better be careful, because biases, I don't mean people's biases, I mean biases in the design of the study and in the type of questions that are asked, not deliberate biases, study aspects, will creep in. And the classic textbook in this area is by Breslow and Day, the standard textbook. And it says, over 5, fine. Start interpreting with a little bit of confidence. If you get relative risk below 2, be very careful, because it could be a bias. So that's the reference. Now here, we're dealing with relative risks very little different from 1. Very tiny different. Just about 10% towards the relative risk of 2. Okay? So tiny risks. So quite clearly, if you can't rely on epidemiological studies at relative risk of 2, you're going to have a great deal of difficulty relying on the results below 2 and close to 1. Okay, so bearing that background in mind, one therefore has to look at all the results of these studies to see whether there could be biases operating. Now, there are biases operating in the workplace measure, there's biases operating in the childhood measure, but they tend to be relatively minor. They don't tend to work particularly very strongly one way or the other. However, with the spousal studies, there are at least 2 very clear biases that have been identified. And nobody, as far as I'm aware, disputes either of these biases. There may be discussions on how strong these biases are, but nobody disputes they exist. And they exist in the spousal for one very strong reason. Remember what we're trying to do by comparing the spousal results. We are taking people who are married to smokers, and we're comparing their incidence of lung cancer against people who are married to never smokers. And we're saying, if we find an increase in lung cancer in that comparison, then that is due to ETS exposure. But there are other differences between people married to smokers and non-smokers. First of all, we take one type of bias called confounding bias. In this particular case, there have been quite a number of studies in recent years, most of them since 1992, I would say, in which the lifestyle of people married to smokers and those not married to smokers are compared. And what you find is that they eat more animal and saturated fats. They eat less vegetables. They eat less fruit. They have more hazardous jobs. All factors which have been associated with lung cancer incidence. So straight away, you've got a potential bias there. Now, the problem with that bias is simply that it's very difficult to quantify. The information is really not available to quantify. Some studies have tried to incorporate some of this in, but really it's early days in the research of trying to understand what exactly people consume. So there's no adjustment in any of those figures for confounding bias, except where perhaps a study has attempted to do it. The second, and generally recognised to be the more important bias as far as spousal smoking is concerned, is called smoker misclassification bias. Now, all these studies have attempted to use never smokers. They've asked people, have you smoked? And many of them have gone to some lengths to find out whether they are correct in making that statement. However, there is a lot of evidence accumulating, and some of the studies provide it themselves, that when a smoker is asked whether they have ever smoked, whether they're a current smoker or a former smoker, there is a proportion of them who will deny their smoking. And it can be quite surprising how large that proportion is. Effectively, in the United States, it may be something of the order, I mean, I've allowed for 2.5% in these studies, but it can be possibly, on average, as high as 4 or 5%. And some studies have found far higher than that. To give you an absurd example, because I think it's very extreme, is recently a study was carried out in Midwest America on people of Southeast Asian origin. And these women were asked whether they ever smoked. And they were also tested to see whether they smoked. You can test whether somebody smoked by the amount of cotinine they have in their body fluids. And of the women who claim to be never smokers, 70% currently were smokers. Now, I mean, that's an extreme example, but it's not so extreme. There have been studies that have picked up 20%. If you ask people in a very extreme situation, it can be very high, you know, if, at intervention clinics and so forth like that. In a neutral situation, it's probably about 2.5 to 4%. Okay, so that in itself wouldn't be a problem, the fact that they, some people mislead. The problem is, there is another factor, and that is that smokers tend to marry smokers. In fact, smokers are 3 times more likely, in most cultures, to marry another smoker. That means when you compare people married to smokers against those who are not married to smokers, most of those misclassified smokers are going to appear among the people who are married to smokers, and that boosts up this relative risk. So you get a spurious relative risk. Now, there's been a number of attempts to take that bias into account, to calculate it. Various methods have been proposed. The first peer-reviewed method of carrying out that calculation was only published in January of this year. I've used that method, and when you use that method, you get the results in our report. So that's a very long answer to why past people perhaps have come to different conclusions from ourselves.
May I add something, and that is that, you know, it would be very difficult nowadays to publish a paper with such a low relative risk. That is because the scientific community believes in what Dr. Springle has said. I mean that if you have a relative risk of less than 2, it would sound as unbelievable. Probably bias and confounding factors, as Dr. Springle has said, would have made the difference.
Thank you. That was a very long and complete answer to your question, and there are some other components too, because the science has changed as well as the epidemiology and other studies during that time. We take another question. Yes.
Can I go to the 1.01 risk? I think even the most rabid anti-smoking sort of groups would say that the actual risk to non-smokers of getting lung cancer from passive smoke is very, very low. So presumably that's a simple proportionality. 1.0 means 1.08 times more likely to get lung cancer.
But that also, it's also non-significant. In other words, there's no reason to believe that's any different from one
by chance. But you
chance.
couldn't really expect a 2 or 3 or 4 or 5% thing, because no one's suggesting that being exposed to passive smoke is a very, very strong carcinogen. So isn't it really a question of being sort of being up in the air rather than being a definite no in either direction?
Well, our conclusion is there's insufficient evidence because science can never prove a negative. We could have 1 million studies out there, and they could all be perfect, virtually perfect studies, but we still could not come here and say it does not cause lung cancer because science can't answer that question.
Did you, when you looked at the spousal studies, did you use 90 or 95% confidence intervals when you
We use what is generally used, which is 95%.
So you used a more stringent test than the
Yeah.
American statisticians did when they...
No, in fact, it's not true. It's a less stringent test. The point is 95 is the normal one. Every agency uses 95. Statisticians worldwide use 95. Nobody uses 90%. The EPA, in fact, loosened the standard. In effect, they produced a significance by loosening that standard. And apart from the fact that some of these corrections and so forth I'm talking about.
So I think there's an independent review after that done in America, and I think someone from New York Medical School said, given the size of the trial, that it was quite acceptable to actually use 90% confidence intervals. You don't accept that, though?
No, not at all. The size of the significance level is connected with the inference you're taking into account, not the size of the study in any sense. It's part of statistical theory, part of statistical inference, nothing to do with the studies themselves. Yes, I read a couple of those points, and to be quite honest, I couldn't really see the sense in them.
So is the bottom line that passive smoking probably causes a few cancer cases, but they're so small we can't definitely say how many or if there are?
We're saying we have no evidence to suggest that it causes any lung cancer cases.
There's no evidence, but you couldn't say it doesn't at all.
Well,
But you couldn't see that for almost anything. Oxygen could cause cancer. How could you prove that? How could you prove otherwise?
So you're comparing it with oxygen.
You could compare it with anything. I mean, you know, water is needed for life. But if you drink too much, maybe you will die.
If you said, I want to design a lot of studies to examine the relationship between walking in the park and lung cancer, we could carry out thousands and thousands of studies, and we would never prove that walking in the park didn't cause lung cancer. It would be impossible scientifically ever to make that statement. That's the nature of science.
Does any of the panel smoke?
yes, the chairman does.
As
As far as I'm
Not the
aware,
others.
none of these gentlemen do, or the other two members of the panel.
Can you just tell for us that maybe in your report what some of the foods are that contain benzopyrene, formaldehyde, and nitrosamines?
That's a rubber one.
Yeah, I think for benzopyrene it's quite classical because every time you fry meat or fish, you produce some of the benzopyrene. So that's with the nitrosamine. Most of the time when you're in nitrate, you can produce nitrosamines because it's all over. Even though there is a discussion about the production of nitrosamine even inside the body and not only outside the body, so we didn't take into account that. Formaldehyde is a chemical which is everywhere, so it's present in almost every situation. But coming back to the point of the diet, I think, and coming back also to one of the questions, when we are discussing so small risk or increased risk, we have to realize that poor dieting is probably a major cause of cancer as compared to those small examples we are discussing. And people who have very poor dietary habits are probably exposed to risk of cancer. And it was quite interesting to realize, when you read the literature, and I think the President and the Chairman said already that one of the cancers which is the most sensitive to dietary intake is lung cancer. That's something which surprises me very much. And if in fact you look at every study which has tried to correlate lung cancer risk with dietary intake like vegetables and fruit, they always found an inverse correlation. There is no study which doesn't show any significant inverse correlation. So it seems that lung cancer is particularly very sensitive, probably to intake of antioxidants. And coming back to the point of Professor Benitez, that's one of the questions we are asking ourselves. In people who have a very low intake of antioxidant, many things could be carcinogen for the lung because everything we inhale could become a lung carcinogen because the protection will be very low. So no, the message is that poor dieting is probably a greater risk of lung cancer than ETS inhaling.
Oh, sure. In the classic paper by Doll and Pito, Journal National Cancer Institute, that is where they say 35% of human cancers are related to various aspects of the diet, and I don't think that's particularly changed over the years since that was reported. There was a question on this side.
Glenda Cooper, The Independent. I think you probably sort of partly just answered it. I mean, what is the relative risk of a poor diet compared with inhaling ETS? You're saying the relative risk is sort of 1.01. Really?
Well, we're saying it's effectively 1. I mean, we're saying there's no reason to believe it's any different from 1. if we carry out an experiment, we're always going to get a value slightly different.
No.
Yeah,
I mean, like,
but
relative
diet,
risk.
I think Professor Roberval is more expert on this, but it consistently gives values below 1.
Yeah, in fact, I spoke about inverse relationship and not direct one. So, but if you compare people who have a high intake of fruit and vegetables, then you go down with risk which are 0.3 or something like that. So you reduce the risk of getting lung cancer. It's not. It has never been worked out in the opposite way.
You may have.
Sorry, I must give this gentleman an opportunity. Right
Yes,
at the back.
Professor, consider that I am from Tiempo in Spain. Consider that you have been working very hard in this report for so long. How you define nicotine? Do you define nicotine as a drug or as a drug-related element? How you define it?
We treated nicotine together with all the other constituents of environmental tobacco smoke as a chemical constituent of environmental tobacco smoke. You may not be aware there was a recent paper which studied inhalation over a 2-year period of nicotine by rats, and then they looked for lung tumours in rats, and nicotine does not cause lung tumours in the rats at a level of inhalation over a period of 2 years at a level which generates blood levels very similar to the blood levels in smokers. So, not that I think it was really in doubt that nicotine was a carcinogen, but at least there has been a long-term study that shows it's not. No, we considered nicotine no different from any of the other constituents, just as a chemical constituent of environmental tobacco smoke. Madam.
You may have gone into this in the beginning, but can you tell us who your sponsors are and why you did this study?
Yes, and it's in the forward on the very first page of the report that you will see in your pack. I was approached by a number of tobacco manufacturers and asked to put together a panel who could investigate the association between environmental tobacco smoke and lung cancer, and that I did. The sponsors, as you put it, those who provided the financing for bringing us all together from the different parts of Europe from which we come in order to meet on a number of occasions, to review the literature and to carry out our work were Philip Morris Europe, British American Tobacco, and Rothmans International Services, I believe, but it is in the report. You have to appreciate, without some sort of funding, this type of work never gets carried out.
Ladies and gentlemen, the fire alarm is about to be tested. Please take no further action. Ladies and gentlemen, the fire alarm is about to be tested. Please take no further action.
Ladies and gentlemen, there is an emergency within the building which is being investigated. There is no need for alarm. Please stand by for further instructions.
Well, we seem to be getting down.
Ladies and gentlemen, the fire alarm is about to be tested. Please take no further action. Ladies and gentlemen, the fire alarm is about to be tested. Please take no further action.
Attention, attention, there is a need to evacuate the hotel. Please leave the building by the nearest available exit or fire exit immediately. Please do not use the lifts.
I'll try again. I think
Ladies and gentlemen, the routine fire alarm test has now been completed.
Good.
Thank you for your cooperation.
You're welcome.
Ladies and gentlemen, the routine fire alarm test has now been completed. Thank you for your cooperation.
Still alive.
It's a comedy. We seem to be getting down to a core of questions from the same journalists now, so maybe if we broke up these formalities and offer you the opportunity to talk to us as individuals one-on-one now for a period before we finish the session.
Can you
I think that's probably...
Quickly, because I was a bit disturbed. The three tobacco manufacturers, those three were the only sponsors. They provided the entire financial backing for the project.
That's right, yeah.
Okay. I just
And finally, I mean, how would you respond to somebody who said, well, you know, this is not me speaking, but it might be a cynical reader, saying, well, naturally, if the tobacco companies have financed the study, you're going to come up with this finding. What would be your reaction to that charge?
Let me tell you something about it. As a clinical pharmacologist, I have served in several committees, national committees and so on, and European committees and so on. And, you know, when the governments pay for somebody to meet, they always have something in mind, which we usually don't comply with, and we are paid for that. So it's very normal for us as scientists to be paid by people that perhaps would like to hear a certain answer, but it's also very usual that we do an independent work. I mean, we do that every day.
Maybe I could reassure you, because we've had to reassure ourselves on this issue at the outset. I was only prepared to do this, and my colleagues agreed to this too in our very first meeting, provided there was no interference, no input whatsoever from the sponsors. They did not attend the meetings. They will see this report when it's released now, at the same time you're seeing it, that they had no part in the production of this or in our work whatsoever, and that we would release this report irrespective of its findings. And when I got an undertaking that that would be the case, then we agreed to do this. I mean, you know, we all have our own lives and our own careers to deal with here. So, and that's really no different from doing running a symposium for a pharmaceutical company on a particular area, or as Professor Benitez has said, also in relation to various government issues. But maybe it would be useful now if we had more of a, if you want to talk one-on-one period. Should we take this as the absolutely last question from them?
Quick last question. Some people, how would you respond to suggestions of naivety, or if someone suggested you're being slightly naive, and that you said earlier you don't want to talk about other things which passive smoke has been implicated in, things like inducing allergies in young children. And if the tobacco companies knew that the chances of you finding no link between passive smoking and lung cancer were quite likely, but you'd actually then do away with the damaging image that passive smoking has in general, that could be one of their plans, I suppose, but on the outset, and would you be kind of duped into doing that?
I don't think so. You see, if you wanted to have a working group that was competent to look at the area of allergy, or look at the area of coronary artery disease, and some of the other associations that have been suggested, you'd need a very big panel. And we took a single brief here, and it may be that somebody should organise one to look at these other areas too. But you know, and I think that's undoubtedly important. But this is the area we've studied. We had enough work with this. You will see our report is single-spaced and very detailed here, and I believe that it provides a platform for a quite major expansion to the level of a considerable monograph on this topic. It was enough work for us, this one subject.
Yeah, lung cancer has always been the major concern with regard to tobacco smokers, so it's quite understandable.
And a difficult enough one.
Okay, is there still coffee, Mr. Johnson?
Coffee's on. The press packs are available at the door, and these four gentlemen are available if you want to talk to the president. Thank you.
Good job.
Yeah.
I don't know if you can ask a question too, but I don't usually focus on it, but has lung cancer been